Okay, so example 7. We've got a particle travelling in a straight line, and it gives us velocity as 5 minus 3t squared. It then asks the distance travelled by the particle in the third second of motion. So firstly, we have to think about what the third second of motion is. So the third second is between the end of the second and the end of the third second. So the third second of motion is between the point t equals 2 and t equals 3. Right, you can think of it by starting from the first second. The first second is from time 0 to time 1. The second would be time 1 to time 2. And the third second is t2 to t3. So all we need to do is find the displacement by integrating the velocity. So the displacement s is equal to the integral of 5 minus 3t squared dt, which this can then be integrated as 5t minus 3t cubed over 3 plus c. So s is 5t minus t cubed plus c. But we've got a slight problem. We've got no way of finding out what c is. There's not enough information there for us. So what we've got to think about is we're going to go back and think a little bit about what v would look like. So if we think about v, we can actually draw the graph fairly easily because we know it's a quadratic. It's going to be U-shaped, it's got a negative value of a and it goes through 5 when t is equal to 0. So when we draw the quadratic, it'll go through 5 like that, and it'll come down here. We just need to check what those roots are. So the roots will be when v is equal to 0, if this is v and this is t. So rearrange, it's t squared equals 5 over 3. So t is plus or minus the square root of 5 over 3, which is approximately, we can find a decimal answer for that. That's t equals plus or minus 1.29. So pop 1.29 in there and minus 1.29 in here. And then we can see that what we're looking for is remember this is the velocity I've sketched, but we're looking for the value between 2 and 3. T is 2 and t is 3. So we can see that both of them are going to have negative velocity between it. And what we're trying to do is we've integrated it to find the displacement, but we can also use another property of the integration, that if we know that the displacement is the integral, well actually what we're doing is we're looking for this area here, aren't we? Yeah? So if we know that's the velocity, the displacement between t equals 2 and t equals 3 is the area under the curve between t equals 2 and t equals 3. That's a property from your year 12 integration work. So actually it doesn't matter that I don't know plus c, because what I'm going to do is evaluate. So instead of doing what I've done here, we can put in 3 and 2 as the limits of integration, and then we can forget about the c, and instead we can evaluate between 3 and 2. That's going to give us the area under that curve. Alright, if I integrate this and I put 3 and 2 as the limits, that will give us the little pink area that I've highlighted here. So all I'm going to do is substitute them in. 5 times 3 minus 3 cubed minus 5 times 2 minus 2 cubed. Okay, pop that into our calculator, work it out. Should get minus 14. So remember what we found out is the displacement. So if we go from velocity to displacement, that will include the direction. So we can see the area under the curve as well as negative, so we would expect to get a negative answer. But if you look in the question doesn't ask for displacement, it asks for distance. So what we've got here is we've got that the distance itself is going to be 14 meters. Okay, so a little bit tricky there, a little bit tricky with the ideas of combining the integration with the idea of an area under a curve and using those limits so that we avoid having to use the plus c, right? Because we know the plus c's are going to cancel anyway, and we don't need them when we put limits into our integration. That's it for the examples. So what we need to do is have a look at 11D now, and the work will be for you to do the odd questions only from the exercise.